Okay, so let's take a look at the information that's shown to us here. It says cyclooxidase is one of the enzymes needed in the formation of prostaglandins, compounds that are involved in causing fever, pain and inflammation. So as always, we should look at the information, read it, and try and make connections with what we've learned in the classroom before we start answering a question, because we don't know which information is going to be important and which isn't. So cyclooxidase, one of the enzymes needed in the formation of prostaglandins. Okay, so if cyclooxidase is an enzyme, we can make some assumptions there about what properties and structure cyclooxidase has. So we should list all of those here before we go any further. So it's needed in the formation of prostaglandins. Now, I've never heard of that before. Prostaglandins, is it important or isn't it? I'm not sure. So maybe we should do a bit of research and find out what prostaglandins are and just double check whether we actually know what they are, if it's something that we've covered in the spec up to now and we've forgotten. Either way, we're not sure, are we? So do some research there. So it's involved in the formation of prostaglandins, compounds that are involved in causing fever, pain and inflammation. So again, these are words that we use every day in life, but are we 100% sure about what they mean? So fever, pain and inflammation. Is that something that we should already know? Let's do some research and find out what each of those things are, or remind ourselves if we've forgotten. Okay, so cyclooxidase catalyses the conversion of arachidinate, I've said that completely wrong, haven't I? Arachidinoate to prostaglandin H2 as shown in figure 1. So they're telling you here what the substrate and the product is of this reaction that cyclooxidase catalyses. So if I was you, I would write that out here just to get it very, very straight in my head what the reaction is, the substrates and products that this enzyme is catalysing. So here's figure 1. Now, as you can see, the cyclooxidase enzyme is actually catalysing the second reaction within a pathway here that actually involves 1, 2, 3 reactions. So the first reaction involves taking a phospholipid and converting it into arachidinate. Okay, so this is actually going to be another enzyme here. Let's call it enzyme A. It doesn't actually tell us within this diagram the name of that enzyme, but there will be an enzyme that catalyses this reaction. And then the cyclooxidase enzyme, as we know already, converts this into prostaglandin H2. And then prostaglandin H2 is converted into prostaglandin, and again that will be catalysed by another enzyme that we haven't been given any information about. So let's call that enzyme B. So there's actually 1, 2, 3 reactions there. Substrate being converted into a product, and then that product becomes the substrate of the second enzyme to form another product, and then this product becomes the substrate of the third enzyme to finally produce the prostaglandin. Now at the bottom here, it shows us that the cyclooxidase enzyme is found attached to the inner surface of the endoplasmic reticulum. So inner surface of endoplasmic reticulum. Now we've heard of endoplasmic reticulum before, and they're showing you a diagram of it here and showing you where the cyclooxidase enzyme is attached to this inner surface. So endoplasmic reticulum, what do we know about that? This takes us back to F211 and the eukaryotic cell structure. So there's lots of information here. For instance, you could start with the 2 different forms of endoplasmic reticulum that you learnt about in F211. So just taking this diagram in, they're showing you where the cytoplasm is. What do you know about cytoplasm? We've got the COX enzyme here attached to the inner surface. So do you even remember what the inside bit here of endoplasmic reticulum is called? This is membrane. What do you remember about that even? So there's lots of information here that's given to you. and lots of assumptions that we can make about what we know already. Without looking at the question, we don't know what's going to be relevant, but this is where we should start, and these are the kind of things that we should be thinking about before we begin to answer the question. So stop the video now before you watch the second video and fill in all of these blanks about information that you should already know about before you watch the second video.